Hi everyone. Welcome back to another Python tutorial. In this video, we're going to build a word cloud generator application using Python and Tkinter. Word clouds are a great way to visualize the frequency of words in a given text. Our application will allow users to input text, choose a color palette, and generate a word cloud that can then be saved. We will also include the feature of importing an image which the word cloud will take the same shape as. And for those who stick around until the very end, I will show you one additional cool trick. Here is an overview of the different methods necessary to build this app. We begin with initializing the constructor, which includes the main window with GUI elements and layout configurations. We then have the generateColorBar method, which creates a color bar image for a specified palette. The color bars will be used to show the user which color are included in each color palette. The importImage method is used for importing an image file as a shape mask. A shape mask defines the word cloud's outline, allowing it to take shapes beyond the default rectangle. The main function for this app is the generateWordCloud method, which is where we will generate the word cloud from the text input from the user. Lastly, we have the saveWordCloud method, which will allow the user to save the word cloud image as a PNG file. With that said, let's start coding. We'll start by setting up our Python environment and installing the necessary libraries: NumPy for handling arrays, Matplotlib for data visualization, Customtkinter for customized features or appearance of the GUI, wordcloud for generating word clouds, Bytes.io to create in-memory binary streams that can be read and written like files, and the Python imaging library for image processing. To install these, open command prompt and type pip install numpy, pip install matplotlib, pip install wordcloud, and pip install PIL. This first line of code sets the appearance mode for the Customtkinter library to dark. If you prefer, you can also set it to light. We then specify the color theme to dark blue. Other options you can try are blue and green. We will be using 3 different color palettes in this project, but there are many more that you can play around with. Just type, from Matplotlib import color maps. Print, list, color maps, and you will get a list of all registered color maps in Matplotlib. For now, let's settle with these 3 and store them in a list called color_palettes. We'll define a class called wordCloudApp that will represent our application window. Be careful not to name this just wordCloud, since that would conflict with the wordCloud class imported from the wordCloud module. Inside this class, we'll initialize the main window with a title and geometry. Create widgets for text input including font, size, and position. Color palette selection with 1 radio button for each color palette. Define the variable selected_palette to keep track of which palette the user has chosen and set the default palette to the first option. Tkinter provides several layout managers for positioning widgets within a window. In our application, we'll use the Grid Layout Manager, which arranges widgets in a grid-like structure of rows and columns. For this application, we center everything around a second column which has the index 1. To get 3 color bars aligned next to each other horizontally in this middle column, we can create an additional frame, an inner frame. This inner frame is positioned in the first column of the master frame. To get the radio buttons and their color bars next to each other, 6 columns are used in the inner_frame. Let's create this inner frame and the content inside of it. We use a for loop to go through each of the color palettes. To display the image, we put in a label. we create buttons and connect them to specific actions by setting the command attribute, which tells the program what to do when a button is pressed. We also create a canvas for displaying the word cloud and a Save button. Here, we're configuring row and column weights to make widgets expandable. This means that when the window is resized, the rows and columns will adjust their sizes proportionally based on their weights. This line configures the row weights for rows 0 through 7. The parameter 0, 1, 2, 3, 4, 5, 6, 7 specifies the indices of the rows to configure. The weight equals 1 parameter assigns a weight of 1 to each row. In Tkinter, weights are used to determine how much a row or column should expand when the window is resized. A weight of 1 means that each row will expand equally. Each column is also configured with a weight of 1, meaning they will expand equally when the window is resized. Finally, we initialize a variable named selected_image_path with a value of none. In our application, the user will have the possibility to input an image to define the shape of the word cloud. This variable is used to store the path of that image. Initially, no image is selected, so the variable is set to none. In our application, we will give the user the possibility to choose between 3 different color palettes. To display these, we need a function that returns a color bar. Therefore, we define a function named generate_color_bar that takes one parameter, palette, which specifies the color palette to use for generating the color bar image. We generate a linear gradient ranging from 0 to 1 with 256 steps. This gradient will be used to create the color bar. np.linspace 0, 1, 256 creates an array of 256 evenly spaced values between 0 and 1. We stack this array vertically to create a 2D array representing the gradient. We create a matplotlib figure, an axis object using plt.subplots, figsize sad smiley 8, 2. This creates a blank figure with a length for times the height. We plot the gradient on the axis using ax.imshow, gradient, aspect equals auto, kmap equals plt.get_kmap, palette. This displays the gradient as an image on the axis. Aspect equals auto ensures that the aspect ratio of the image is automatically adjusted. Kmap equals plt.get_kmap, palette, sets the color map of the image to the specified palette. We turn off the axis lines and labels, using ax.axis, off, to remove unnecessary visual elements from the plot. We save the plot as a PNG image to a bytes.io buffer and specify the image format. In matplotlib, when you save a figure as an image, e.g., PNG, it's often surrounded by white space, which is referred to as padding. This padding ensures that no part of the figure is cut off when saved. By specifying box_inches equals tight, we instruct matplotlib to adjust the bounding box, the box that encompasses the entire figure, so that it fits tightly around the contents of the figure. Setting pad_inches equals 0 effectively eliminates any extra space around the image. After generating and saving the plot as an image, the image data is temporarily stored in a bytes.io buffer. Bytes.io is an in-memory binary stream, which means it allows you to treat binary data as a file-like object in memory. The buff.seek 0 statement is used to move the current position within the bytes.io buffer back to the beginning, position 0. Now, let's write a function to allow the user to select an image file from their file system to define the shape of the word cloud. We use Customtkinter.fileDialog.AscOpenFilename to open a file dialog box. This dialog box allows the user to navigate their file system and select an image file. The AscOpenFilename function is part of the file dialog module in the Customtkinter library. It returns the path of the selected file. Initialdir specifies the initial directory to be displayed when the file dialog box opens. Here, it's set to the root directory, but you can set it to any directory you prefer. The title sets the title of the file dialog box to select image file. This title will be displayed at the top of the dialog box. The file types argument specifies the types of files that can be selected. In this case, it allows only image files with extensions .png, .jpg, and .jpeg. The path of the selected image file is returned and assigned to self.selected_image_path. Now, let's create the function that generates the actual word cloud. First, we need to retrieve the text entered by the user in the text entry widget. The arguments specify the starting and ending position of the text to retrieve. End1c is a special index that represents the position just before the last character of the text widget. Let's also store the color palette selected by the user by using the get method. Remember that the user would have the possibility to input an image that would define the shape of the word cloud? Now, we will check this to see if the user inputted something or not using an if statement. We use a try-except statement here to handle potential errors that may occur during the process of opening, resizing, and converting the selected image. A try-catch statement allows you to attempt a risky operation in a try block and handle any resulting errors in a catch block so that you avoid crashing the whole program. In the try block, we begin with opening the selected shape image. We then resize the image. Here I have chosen a size 3 times larger than what will actually be displayed. This is because this is the size that the user will be able to save later, and the larger the image is, the better quality it will have. We then change the image to grayscale by inputting L for luminance. Convert the image to a NumPy array to be able to use it as a mask for the word cloud. The last step is to create the actual word cloud object. We set a width of 1200 pixels, a height of 750 pixels, a white background color, a color palette specified by palette, and a mask generated from the grayscale image mask. It then generates the word cloud based on the input text using the specified parameters, and assigns the resulting word cloud to the variable self.wordCloud. In the else statement, we define the word cloud in the same way, only without the mask. We finish by resizing the word cloud image to 1/3 of its original dimensions to fit the Tkinter window better. We then save the resized image as a PNG format in a bytes.io stream. Next, we opens the image from the stream, convert it to a Tkinter-compatible photo image object, and display it on a canvas widget anchored to the top left corner, northwest, of the window. Finally, it updates the canvas image attribute to store the displayed photo. Now, we finish the app by creating the method that is used to save the final word cloud when pressing the button. We prompt the user to select a file name and location for saving the file using a file dialog box. If the user selects a file name, meaning they didn't cancel the dialog, we proceed to convert the word cloud into an image format. Finally, we save this image to the specified file name location with a .png extension. As a final step, we define a main function. Inside this function, we create a Tkinter root window which serves as the main container for our application. Then, we initialize our word cloud app class, passing the root window as an argument. Afterward, we call the main loop method on the root window to start the Tkinter event loop. Finally, we use the if name equals main block to ensure that the main function is executed only when the script is run directly, providing a clean and organized structure to our Python application. Thereafter, we run the Python script. Let's take the Python code as text this time. Press Ctrl A to select everything, Ctrl C to copy and Ctrl V to paste into the text area. Now we get to choose which color palette we want. Let's take this one. I have this apple that I will choose as a mask. Now just press this button and we have our word cloud formed as an apple. Choose another palette and it will update when you press the button again. Also, if we lift this window up a little, we have the Save button right here. Now for the final trick that I promised you. Scroll up to the Generate Word Cloud method and add this first line. If your mask is a little complicated, try uncommenting this other line as well. By doing this, the word cloud will be inverted. Pretty cool, right? Thank you all so much for watching. If you enjoyed making this word cloud app, make sure to show your support by hitting the like button and subscribing for more tutorials. Also, don't forget to share your thoughts in the comments below. See you next time. Until then, I wish you all some bug-free coding.